Hello, and thanks for watching. My name is Alfred, and welcome to TerraForge Motorsports. Today, I'll be working on the Junkyard Super Duty 60 axle. I'll be swapping her a Jeep JKU. But before I do so, this axle is going to need some work. Now, I have some tools laid out in front of me, and some of you guys may be able to guess what we're doing today. But if you don't know, don't worry, that's okay too. Today, I'll be taking off the diff cover and installing an ARB air locker and installing that with a set of Nitro gears. Now, if you're new to gearing, don't worry. I'll be there guiding you through each step along the way. And although I'm specifically working on a Dana 60 axle, the information and processes that I'm giving you today is still applicable to the Dana 30, 40, 50, 70, 80, and all the other axles out there on the market. Now, the tools I have in front of me, it's going to make the install pretty fast and going to reduce the risk of damage to any of our new components. Not all of them are completely necessary, but if you have the care and patience, then you can too do your own gears at home. With that being said, let's get to work. When doing gears, you want to make sure your work area is free from metal shavings and just dirt and debris. Normally I use a stainless steel table, but I actually got the 14 bolt currently resting on that. So I'm just going to use this my old workbench. I'm just going to clean it up real quick and it'll work just fine to do gears on. So as you guys can see behind me, I have all my parts laid out for this axle build. I have my ARB air locker, my USA standard master install kit, and I also have my Nitro 513 gears. Now, when it comes down to axle builds, it really is, you can pick and choose whatever parts you want to use. For this one, for the locker, I decided to go with an ARB for a couple reasons. Number one, it's selectable. And number two, which is the bigger reason, is that it's going to match the locker that's going in the rear, because that's also using an ARB. For the rear locker, there's not much aftermarket support when it comes down to selectable lockers. ARB is one of the better options out there, and that's the one I decided to go with. For the master install kit, I decided to go with USA standard gear. I've used them in the past and never had any issues with missing or damaged components, and the bearings they use are KO, which is a good quality bearing. For the gear set, I decided to go with the Nitro Super 60 gears. Now, what makes this gear set different from, just say, any other standard Dana 60 gear set out there is that this one measures at 10 inches across, as opposed to a standard Dana 60, which would be 9 3/4. They use this gear set size in the F450s and 550s. And for this build, the typical F250, 350 Super Duty, this gear size still fits. So by increasing the diameter by just a 1/4 inch, we're going to have additional strength built into the gear set. But as you guys can see, all the parts are laid out. It's time to start cleaning them up and putting them together. When gear manufacturers ship their gears, they normally coat them in a grease, waxy type of material, just to prevent corrosion from shipping, and then if it just sits idle on a shelf. Normally, brake clean takes that stuff right off. And the reason why I want to take it off is so we have a clean machine surface so we can press our bearings onto. So what we'll do is we'll take some brake clean and start wiping them down. And good gear practice would be taking a flat file like this one right here and going over the face of that gear and making sure it's as flat as possible with no burrs sticking up. Because we want to make sure that that face is flushly mounted against the face of the differential. Now another thing that you want to consider is to see what the interference or how tight that gear sits on the differential. 9 times out of 10, they are pretty tight. So you have to throw that gear in the oven for 15 or 20 minutes and get that to expand so it sits flatly against the differential. What you don't want to do is take those ring gear bolts that comes in our install kit and use those to drive the gear down, because last thing you want to do is pull the threads out of that gear that you just spent all this money on. And I'll show you guys how tight my ring gear is on the ARB, and then if we have to, we'll throw it in the oven. With our new ring gear heating up in the oven, we have about 20 minutes to kill. So what we're going to do is we'll knock out the old pinion and the old races in the housing, and then we'll set up our new pinion with our new bearing, take the original shim and install it onto the new one, and that'll be our initial setup. And then what we'll do is we'll take the go back to the housing, knock out the old races, and pound in the new ones. Alright, what we'll have to do now is we'll take off the crush sleeve, and then we'll have to grab our clamshell puller because we have to pull this pinion bearing off because there's a shim between the head of the pinion and the bearing, and we need to know what that measurement is. The proper way to use this clamshell puller is using the race on top of the bearing to pull the bearing off. Unfortunately, I forgot to install it here. Luckily enough, we're not reusing the old bearing, so any damage isn't a concern. With the housing all cleaned up, we're almost ready to start pounding in our new races. Before we do so, we gotta take a couple measurements. The measurements we need is gonna be from the original oil baffle and this pinion shim, because together, this is what our original pinion depth was. So what we're gonna have to do is take our new baffle, supply it in our master install kit with our original shim, and then we're gonna put this together and we'll figure out what this measurement is. And from here, we'll either add or subtract shims to the pinion shim so we can equal out to what our original measurement was. And for this is just an initial starting point to kind of get us close within the ballpark of our pinion depth. Because after we get the pinion installed into the housing and get our gears all set in, what we'll do is we'll paint a pattern. Depending on where it is, we need to make it deeper or shallower, we'll just add abstract shims to the pinion side. So we just gotta break out some calipers and start taking some measurements. And when measuring the oil baffle, you want to measure here on the outside edge, because that's where the race is going to be sitting. And because the baffle itself is so damaged, I take a number of measurements and try and figure out what an average is. So for this one, it's looking like it's pretty much 18 thou. So with our measurements, we found out our original shim measured at 40 thou and our baffle at 18 thou, which gave us a total measurement of 58 thou. So since we're reusing our shim for our initial setup of 40 thou, I measured the new baffle, which this rarely works out, but it ended up being 18 thou as well to give us our same depth of 58 thou. Now, depending on what your new baffle is, you will have to add or subtract shims to your stack underneath the pinion bearing. Because what you want to do is, for initial setup, you want to have your depth to what your original was. Like I said, we'll adjust that accordingly depending on what our actual pattern reads, but for this, hopefully this makes sense. To install these races into the housing, I'm going to be using this Icon master bearing installation kit that I picked up at Harbor Freight. It does come with all the adapters typically found for any gear job, and for the drivers, it actually comes with two different styles. It comes with one here for an air hammer, which is the one I'm going to be using, and it does give you the traditional style where you set the adapter on to the driver and pound it into a hammer. But since I have my air hammer, pounding these races is going to be pretty easy, so I'll show you guys that. With our new race, we'll add some gear oil to it just to aid in the installation of it. And the oil baffle is directional, as you can see here with the race point. We just want to make sure that this end is pointed away from the pinion head. Well, I guess it's time to grab our gears. ring gear seated on the locker and all these ring gear bolts just snug down, what I'm going to do now is I'm just going to mark on the ARB a quick little torque sequence. Then what I'll do is I'll start at number 1, I'll pull that bolt out, put some red Loctite on it, and then torque it to spec. And for your guys' reference, I'll throw the torque spec over here in this corner. The proper torque spec for these ring gear bolts to the ring gear is 110 foot-pounds. And with the gear mounted to the locker, this whole assembly is very heavy and awkwardly shaped. The best way that I found to get this torque spec is to throw everything into the press and press everything down. And the force from the press is enough to prevent this from turning while we're torquing it down. And a couple things I keep in my toolbox just as handy tools is old bearing components or remnants of bearings. As you can tell, this one does not have a cage or the rollers in it, but it does have a slit. So what I'm going to do is when I press this bearing on, it's going to give me something to press on to get it all the way seated onto the ARB. And then since this has a hole in the top, what I normally do is I take this aluminum piece of just random piece of material stock and then put it here. And then I'll grab a socket from the toolbox, add in that distance, and then we'll press the bearing and fully seat it onto the ARB. And as you can see, the bearing's seated perfectly without any damage happening to it. Now the other side, it's going to be a little bit trickier, just because as you can see, the cage on this bearing sits higher than the differential. So if we flip this locker over and try and press on the other bearing, what we're going to do is damage the cage and make this bearing useless. So what we're going to do is we're actually going to grab our second discarded bearing, the one with the slit in it, and we're going to set this up just like this, but upside down, and then we're going to perform the same press on the top side. And a good way to know you're in a good position where you're not going to cause damage to this bearing is if you can rotate the bearing and you don't feel the, say, the friction of this cage riding on this old inner, then you should be pretty good. And as you guys can see, I am wearing safety glasses. One phobia I always have, I don't know why, which I don't think it would ever happen, especially if I'm doing this right, is having my face right here watching this press down and just having this cage blow up and having the rollers just blind me. So it's a phobia, but it's one of those things. If I have my safety glasses on, at least I'm not losing my sight. And see, I'm also checking the lower one as well, making sure that we're not doing any damage. During a gear install, one thing to consider is the method you're going to use to set your pinion preload, or how firm these bearings are seated in their races. Now there's two methodologies out there to use. You can either use a crush sleeve or a crush sleeve eliminator. And there's pros and cons to each. A crush sleeve, a pro is that it's pretty simple. It goes on during your final assembly. You'll put your yoke on it, your pinion nut, and you'll keep torquing the nut down until you get your value for your rotational torque. And once that's set, you're good to go. Now, a drawback to this is anytime you have to remove that pinion nut and the yoke, is just say to do a pinion seal, you release the tension from the crush sleeve. And the problem with that is when you go to torque everything back down, you don't know what that value is. So there's a chance you could over torque it and keep compressing the crush sleeve down, and now your bearings are over torqued. Or if you don't tighten down enough, you don't have enough pressure on the bearings in the races, and now this pinion is just going to wobble around. For this axle build, we're going to be using a crush sleeve eliminator. Now, a drawback to a crush sleeve eliminator is that we're going to have to use shims in the spacer to determine our pinion preload, or the distance between these two bearings. And then we'll take this and we'll install it on the axle and then torque down the yoke and the nut. Now, one of two things can happen. Well, potentially three, but the third one is that we hit it on the first shot, which that won't happen. But like I was saying, a couple things can happen. One of them is that we might have too many shims in our stack, and the space between the bearings might be too much, and the bearings may not be seated in their races, which would cause the pinion to be pretty sloppy. Or the opposite could happen, where we may not have enough shims in our stack, and as we go into tying down the yoke and the nut, we might seat the bearings in their races before the nut and the yoke are fully seated, which that would be too much preload. So it's a balancing act between the two of those. But once we actually have this value set, if we ever had to take the nut, the yoke off to do a pinion seal or such, as we reassemble it back together, we can't over torque this because this space is set and this won't change. Unlike a crush sleeve where you can keep crushing this down, and you may never know what your torque actually is. So it's gonna be a lot of back and forth, installing, uninstalling to figure out what this value is. But at the end, it's going to be an upgrade and definitely an improvement over the original crush sleeve. To give us a rough idea of how tall to make the new crush sleeve eliminator, what we'll do is measure the original crush sleeve. And what we'll do is we'll take the original height and then subtract that from the spacer. And the difference that we would have will be made up with the shims provided in the kit. Now normally I would go through and take a torque wrench and torque this nut down to 250 foot-pounds. But with my Milwaukee, I knew that I bottomed this nut out on the pinion before even reaching that. Because if you guys can hear, there is still slop between the bearings and the races, which means we have too many shims in our stack, and now we need to remove shims to close that gap up. So what we're gonna have to do now, take the pinion out, move some shims, and do it all over again. Now, if you guys saw earlier, I marked out all these shims, and for me, it's just a quick reference point to know what I have and what I'm taking out. Because I could take out the calipers and keep measuring them, but for me, that's just a waste of time. So right now, we know we have too many shims in the stack, and from here, it really just kind of goes down to educated guesses. So since we still had a lot of slop, what I'll do is I'll take out, let's say the largest one, so 17th valve, and I'll put everything back together. If we need to take out more, I'll keep taking more out, but if I know that we overshot it and now we have too much preload, then I can split the difference until I keep narrowing in to get what our value needs to be. And with this shim stack, we're definitely getting closer. From the first one, I don't know if you guys could hear, but we had a lot of play between the bearings and the races, and this doesn't exist. The only thing that we have a problem now with is that we haven't reached our rotational torque. Just because by feel, I know we don't have enough. The spec is 17 to 30 inch-pounds, so we're definitely in closer, but not quite there yet. So at this point, I'm gonna start removing 2 thou at a time, and then hopefully we can start dialing it in. For this one, I'm gonna try and shoot for 24, but we'll see how close we can get. With the pinion nut snug down, we rotated the pinion by hand, and we know just by feel that we're pretty close. So what I'm going to do now is I'm going to take my torque wrench and torque the pinion nut to 250 foot-pounds. So normally there's actually a tool, a holder, to prevent the yoke from turning, but using a pipe wrench and a jack stand, that'll give us the support that we need to get this torqued. To check rotational torque, we are going to use this beam style torque wrench, and the spec that we're looking for is between 17 and 30 inch-pounds. And our number that we're looking at right now is approximately 22, so we're within spec. With our pinion currently set up, now what we can do is install the inner axle seals from our install kit, which are these two guys right here. The tool I'll be using is a seal driver tool, and it definitely makes this job pretty easy. If you guys ever wondered what the holes are on the side of the axle housing, it's for a piece of equipment called a case spreader, which that's what I'll be using today right here. And the way it works is that these dowel pins go into those holes, and then with this jack screw, we'll open it up, which is going to spread the axle case open. And the reason why we do this is so our locker and shims fit into the housing a lot easier. Not always necessary, but definitely makes your job a lot easier. But we don't want to overspread our housing because, like metal, it can only go so far before it rebounds back to its original shape. So what we're going to do is we're going to take a dial indicator and place it on the housing. And as we open this up, we just want to make sure we don't exceed 15 thou. So what I'll do now is I'll set up the case spreader and show you guys what I'm talking about. With the locker in place, what we're going to do now is push it off to one direction. And what that's going to do is open up this gap over here on this side. And with this gap, what we're going to do is take some shims and we're going to start stuffing it behind that race. And what we want to do is keep adding shims until they become difficult to pull out. Now, one thing to remember is this is going to be really tight with these shims. We don't want this to be able to pull out by hand. But another thing to consider is that this case spreader has opened up the differential by 15 thou. So when we release the tension, everything's going to suck back together and give us additional carrier bearing preload. Now, carrier bearing preload isn't something that we would typically measure during a gear install. The typical rule of thumb is you can't have too much preload, but what you don't want to happen is not have enough where this differential is going to be shifting back and forth. So I'll show you guys what I'm doing. And the shim stack I just put in here is a combined total of 78 thousandths. Just before this one, I didn't have the camera rolling. I did have an additional 2 thou part of this one. But that being a total of 80 thou, this carrier had a very hard time going in and coming out. So right now it's pretty snug. There's slight resistance, which I'm pretty happy with that. Because like I said before, as soon as we release the case spreader, the whole differential is going to shrink down a little bit more and give us even more carrier bearing preload. So all I need to do now is, since I know what my carrier bearing preload stack is, now I need to divvy it up. Because right now they're all on this side of the carrier, which of course I don't have any of the caps on, but I just know by the sound I have way too much backlash. So what I'll have to do now is start shuffling the shims around and then getting the backlash within its spec. So we got our shims divvied up, and honestly it was one of those things I just kind of split it up 50-50 from our initial measurement of 78 thou, and it sounds pretty close, but I'll fully assemble this, remove the the case spreader and actually check the backlash. But one thing of concern is during assembly, you gotta be mindful of the seal housing, just because this copper tube and the solder is very delicate. So when you go to install the carrier bearing, you just gotta be mindful to make sure your copper line is routed in a good spot where it's not gonna get pinched or bound up. It's a really close fit, but we'll have to keep manipulating this until it fully clears everything. With the bearing caps all torqued down, I threw the dial indicator on the ring gear to see what our backlash was. And surprisingly enough, we are about at 7 thou, and the spec for this Dana 60 is between 6 and 10. So definitely happy about that. That never happens. So since we're in spec now, what we can do is take off the dial indicator and paint the gear and see what our pattern is. And from that point, we'll have to see if we have to make any adjustments for our pinion. Looking at our pattern, it appears that we're still a little shallow, about 5 or 6 thou, which isn't too bad using the original shim that came out of this axle. But what we're going to do now is we'll have to pull everything back out, adjust the pinion shim, readjust backlash, and then check it again. If you guys are familiar with gearing, then you know what this process is. It's a lot of trial and error. But we'll go ahead, pull everything out, and do it all over again. So we just added 6,000 worth of shim beneath this inner bearing, and that was to increase our pinion depth to get hopefully a better pattern. Now, adding a shim here is also going to affect a few other things, and one of them is going to be our pinion preload, because effectively what we ended up doing was we decreased the distances between these two bearings. So what we're going to have to do is, since we added about 6 thou here, we're going to have to take our spacer and shims back off and add another 6 thou worth of shims here, and hopefully that keeps our measurement. But we'll throw the pinion back in, torque it down, and then we'll also check our rotational torque again to make sure we're still within spec. With all the steps that we just took of adjusting the pinion depth and the pinion bearing preload and the backlash, it looks like our pattern's actually looking pretty good. It's pretty well centered. So an adjustment of just 6 thou was pretty good. So what we're going to do now is we're going to take everything back out again, luckily not make any adjustments. The only thing we got to do is tap a hole for the airline, for the ARB bulkhead, for the airline to go through. And along with that, we're also going to have to put the seals in the ARB seal housing. We're almost there, just a few more things left to do. An ARB is known in the off-road industry as being one of the best air lockers available on the market, but there are some drawbacks to it. But mostly it deals with the seal housing. And not because it's a bad product, it normally comes down to installer error. Now, the way this can fail is a few different ways. This copper line, which is a soft material, can get pinched and crushed and create an air leak. And then same thing goes for the solder joint that's down here. If this line gets manipulated too much, the solder could fail, resulting in a leak. Now, one thing that gets a lot of people are these O-rings, and there's two of them, and they sit within the grooves of the housing. Now, during installation, sometimes these can get pinched, rolled, or damaged, and creates an air leak. Now, what makes an air locker is air pressure. So anytime we develop an air leak, either being in our seal housing, our lines going back to the compressor, or if our compressor fails, it results in the system not working fully or not at all. But during our installation, we'll just be careful to make sure none of those things happen. To aid in installation and prevent damage to these O-rings, I applied gear oil prior to installation. We just wrapped up on our final assembly. I did go back through and check the pinion bearing preload, which that was good, my backlash, along with my pattern, and nothing changed, so I was really happy about that. So what we gotta do now is start routing this copper line from our seal housing and avoiding anything or any contact against the carrier bearing, the locker, the gears, or even the housing itself. Because like I said, we don't want to cause any damage to this line because that's going to compromise our system. What we're going to do is at the end of this line, it's going to end up going through the bulkhead fitting that we installed earlier. And as we start contouring this, one thing to remember is that we are running a Super 60 ring gear, a 10-inch ring gear. So our tolerances at the top of the housing are a little bit tighter than a normal Dana 60, so something to be mindful of. But what we'll do is we'll get this routed, and then we'll bench test the locker and make sure everything works. So as you guys just saw, our copper line is now cut to length. You probably saw me use a grinder, which is definitely not recommended. Definitely use a tubing cutter, but mine's somewhere over there. I couldn't find it. But if you're not familiar with the bulkhead fittings from ARB, I'll do a little rundown for you. So this is the components of the kit. So what's going to go in first is going to be an O-ring, a spacer, another O-ring, and then the compression nut. We'll make sure this compression nut's just snug down but not over tight. And then when we install these O-rings, make sure they're coated in gear oil. And then once that's installed, then we have our compression fitting for our airline, our nylon airline, which this will screw into the bulkhead, and then this compression collar and nut is what actually grips that plastic line and prevents it from leaking and pulling out. This quick connect fitting, this will go on your ARB air compressor or power tank, or whatever air source you're using, just a quick disconnect. Now some other components that are part of the bulkhead kit are these guys right here, but this is if you wanted to run your airline out like 90 degrees instead of straight up from the axle. Not something we're gonna be doing, so these are the components that we're gonna be using. With our bulkhead fitting installed and connected to our seal housing, what we're going to do now is bench test it to make sure everything works as it should and that we have no air leaks. Now one tool that I made to do this is this air gun from Harbor Freight. The brand is Merlin, and I end up changing the tip out for this quick disconnect that came in our bulkhead fitting kit. What I'm going to do is I'm going to connect this guy to some nylon airline that came in with our ARB air kit. I'm going to use the compression fitting and connect the airline to the bulkhead fitting that we just installed. Then I'm going to charge the system to 90 psi. At 90 psi, everything should engage. But I'll install the shafts just to make sure that they turn both the same direction. Now, when we pressurize the system, we're only going to pressurize it up to 90 psi. Anything above 90 psi is internal damage to the locker, which we don't want. My shop air here should be 90, but I'm definitely going to double check it before continuing any further. But hopefully we did everything right, avoided any damage, and everything should work as it should. With our axle all set up and ready to be tested, we're about ready to test the locker. But before I add air pressure to the system, let me show you how the axle performs without it. What I'm going to do is hold the driver's side axle shaft and spin the pinion yoke. You're going to see the gear turn, and you'll see that the passenger side axle shaft is also spinning. And this is just an open carrier, no different than what the Super Duty would have came with originally. What we're going to do now is we're going to take our air supply and our chuck, and we're going to charge the system with 90 psi. Now if you listen close enough, you actually might hear the actuator engage. With the actuator engaged, we're going to do the same test. This time though, you can see the driver's side axle shaft spinning, and I can't stop it from doing so. Well, that means that our carrier is locked to our axle shafts, and those axle shafts are going to spin at the same rate of speed. And to go back to an open carrier, the only thing we have to do is just remove the air pressure. And once released, you can see we're back to where we started. During all that, I didn't hear any air leaks, but I'm going to go back through, charge the system, and use some soapy water, and just to confirm there's no tiny leaks exist, the ones I just can't hear. And if I don't find any air leaks, that just means that this axle is just one more step to being done. The Super Duty axle has been geared, the shop has been cleaned, and all the tools we had out today have been put away. Knocking out the gears in the Super Duty 60 axle was a big step forwards to getting it completed, and a bigger step forwards to once on swapping the Jeep JK. Now the 14-bolt build was done a few months ago, and the only thing stopping the 60 from being completed is just waiting on a few more parts to arrive. As a newcomer, gearing can be overwhelming, but as you learn the process, just like the one from today, and gather more tools, then the gear job becomes second-hand nature. Now, if you enjoyed the video, please let me know in the comments, and if you want to get your hands dirty, learn a few new things, and go on some wild adventures, definitely subscribe to the channel. I truly thank you all for watching, and I'll be sure to catch you all on the next adventure. I got hot.